Okay, let's jump in. For today's deep dive, we're unpacking a really fundamental piece of networking hardware.
We are.
It's the Thor broadcast F-PLC-1x4-LGX, basically an optical splitter. And we're going to figure out what specs actually, guarantee you're getting a good signal.
That's the mission, right? To see what the infrastructure designers are really looking for. This little box takes one incoming light signal and splits it into 4 separate outputs.
And it's not cheap. I'm seeing $350 here.
Exactly. $350 with a 2-year warranty. Its job is just absolutely critical, reliable signal distribution. Every single flicker of light counts in these networks.
So physically, it's housed in what's called a compact LGX module.
Right, which is a standard size. It just slides right into a bigger 19-inch rack.
But when we're talking about splitting light, the first thing I think of is loss. How much of the signal do you lose? What defines the quality of that split?
You've hit on the single most critical metric. It's called insertion loss.
Insertion loss.
Yep. And you can think of it as like a tax on the connection. It's the amount of light strength you lose just by passing through the device.
And for this one?
For this 1x4 splitter, the loss is specified as 4 dB. Keeping that number low is just vital.
Because every connection point adds up.
It adds up. This low loss rating is pretty much what justifies that price tag. You're paying for guaranteed signal fidelity.
Okay, so something else jumped out at me here in the specs. The durability. They highlight a really extreme operating environment. We're talking negative 40 degrees Celsius up to plus 85. Why?
That range is a massive, massive design feature. It means network providers don't have to build these, expensive climate-controlled rooms for them.
Ah, so you could just stick them in a box on a pole somewhere.
Exactly. In a utility box, a cabinet, whatever. It simplifies deployment, and you completely avoid ongoing HVAC costs. It's also built with G.657A fiber.
Which is important because
it's bend insensitive. When you're in a tight installation space and cables have to make sharp turns, this stuff prevents the signal from degrading.
So we've got a tough, low-loss splitter, but the next point of failure would be the termination, right? Where the cable actually connects. Why do the connector types matter so much?
It all, and I mean all, comes down to aligning the light.
Okay.
Every connector uses a tiny ceramic sleeve, it's called a ferrule, to perfectly line up these hair-thin fibers. If that alignment is off by even a micron, your loss just skyrockets.
So let's talk about the industry standards right now. What are people actually using?
Well, you mainly see 2 dominant types today, the LC and the SC.
LC and SC.
The LC connector is what you want for high-density environments. Think crowded server racks. It has a tiny 1.25 millimeter ferrule, and it's a simple snap-in.
And the SC?
The SC is a bit older, but still very common. It uses a larger 2.5 millimeter ferrule.
Wow.
Also a snap-in, great for quick patching, but it does take up more space.
The source also mentions ST and FC connectors. If everything is pushing for more density, why even talk about these?
Because legacy infrastructure is still out there, you're going to run into it.
Ah.
The ST has this unique bayonet twist lock, and the FC is a screw type. Both use that bigger 2.5 millimeter ferrule, but yeah, they're definitely being phased out for the faster, denser LC and SC types.
Okay, so let's zoom back out. Where does a splitter like this actually live in the network? What does this enable for you listening at home?
This is the literal building block for modern broadband. It's absolutely essential for fiber to the home, or FTTH.
FTTH, right.
And that's part of the bigger FTTX fiber to the point deployment. Crucially, it's integral to passive optical networks, PON or GPON. That's the gold standard for delivering shared fiber to residential areas. One signal from the central office can reliably reach multiple homes.
So the key takeaway here is that a single $350 component like this can be the quality bottleneck for an entire neighborhood, and it all depends on that low insertion loss and toughness we talked about.
Absolutely. And while the F-PLC-1x4-LGX is a specific example, this tech scales dramatically. You can get splitters that are 1x2, all the way up to a really complex 2x64 split, which, it raises a really interesting question for you to think about. How do network architects even choose that optimal split ratio? If you're building in a dense city versus a sprawling rural area, that choice, that split ratio completely dictates the power budget and the entire design of the network.